I want to start with a number, not a famous one, not the kind of number that appears in textbooks or anniversary retrospectives, or the commemorative plaques that cities put on the sites of things they're proud of having built. The number is 563. That is the estimated number of large-scale glass and iron public structures erected across Europe, North America, South America, and Asia between 1840 and 1900. Not greenhouses, not conservatories attached to private estates, not the small glass additions that Victorian merchants attached to their townhouses to grow tomatoes in winter. Large-scale public structures, civic in scale. The kind of building a city puts at its centre. The kind of building you name. I found the number in a survey compiled in 1923 by a German architectural historian named Heinrich Brandt for the Prussian Academy of Arts. The survey itself was never published. I found a reference to it in a footnote in a 1947 monograph on iron construction, obtained the survey through a request to the Staatsbibliothek in Berlin, and spent several weeks going through it. Brandt was meticulous. His methodology was conservative. He included only structures that could be verified through at least 2 independent contemporary sources. He excluded anything he considered ambiguous. Of those 563 structures, fewer than 12 survive today in anything approaching their original form. I showed Brandt's survey to an architectural historian at a university I won't name because she asked me not to. She looked at it for a long time. Then she said, "That number seems high." And then she said, "But I'm not sure why I think that." That's where this begins. Let me tell you what we're told about the Crystal Palace, because if you know anything about glass iron architecture from the Victorian era, the Crystal Palace is the story you've been given. And it is a story so clean and complete and satisfying that it leaves very little room for questions. In 1850, a man named Joseph Paxton, a gardener, famously a gardener who had designed greenhouses for the Duke of Devonshire, submitted a design for the building that would house the Great Exhibition of 1851 in Hyde Park, London. His design was selected over 245 other submissions. The building was constructed in the extraordinary time of 17 weeks. It was 563 metres long, 124 metres wide, 39 metres tall at its highest point. It contained 84,000 square metres of glass. More glass than had ever been used in a single structure in the history of human construction. It housed over 100,000 exhibits from 28 nations. 6 million people visited it during the 5 months it was open. After the exhibition closed, the building was dismantled. Not destroyed, dismantled. Moved piece by piece to a new site in Sydenham, in the south of London, where it was re-erected, enlarged and opened to the public as a permanent attraction in 1854. It stood there for 82 years. On the night of November 30th, 1936, it caught fire. The fire burned for most of the night. Hundreds of thousands of people watched from surrounding hills. The glow was reportedly visible from 8 counties. By morning, the Crystal Palace was gone. What remained was photographed and then cleared. The site stood empty for years, then decades. Today, it is a park. The official story is clean. A wonder of the industrial age, a showcase for Victorian ambition, destroyed by accident. An ending, but a legible one. A building that had its moment and then, in the nature of things, disappeared. But here's the strange part. Here's the part that first pulled at my attention. Joseph Paxton was a gardener. I don't say that dismissively. Paxton was genuinely brilliant. His work at Chatsworth, designing the lily house for the enormous Victoria Amazonica water lily, showed real engineering intuition. He understood glass, he understood iron, he understood how to span large spaces with minimal structural weight. But the Crystal Palace was not a greenhouse scaled up. The engineering of the Crystal Palace involved solutions to structural problems that had never been solved before. The problem of wind loading on a glass skin of that scale. the problem of thermal expansion across a 563-metre iron frame, the problem of acoustic management in an enclosed space of that volume, the problem of controlling internal temperature, humidity and light transmission across 84,000 square metres of glass. These were not problems that a gardener, however brilliant, would have had a framework to solve, and yet he solved them. In 9 days. That is the documented time between Paxton's initial sketch on a piece of blotting paper and the submission of complete engineering drawings. 9 days. The official explanation is genius, individual exceptional genius of the kind that occasionally appears in history and accomplishes the impossible. I don't dismiss that possibility, but I keep returning to the 9 days, and to something else. The something else is this. Paxton's design was not novel. Hold on to that for a moment, because this is where the official story begins to fracture. When architectural historians examine the Crystal Palace alongside the other major glass-iron structures of the same era, and there were many because this is the part of the story that the Crystal Palace narrative tends to obscure, a pattern emerges that the genius of Paxton explanation cannot adequately address. The Palais de l'Industrie in Paris completed 1855. The Munich Glass Palace completed 1854. The Dublin Crystal Palace completed 1853. The New York Crystal Palace completed 1853. The Glaspalast in Stockholm. The Winter Gardens in Brussels, Vienna and St. Petersburg. These structures were not copies of the Crystal Palace. They were not built by people who had studied Paxton's plans and applied his solutions. They were designed, and in many cases already under construction, before the Crystal Palace opened. What they share with the Crystal Palace is not a copying relationship. What they share is a suite of structural and dimensional decisions that appear independently across buildings designed in different countries, by different architects, using different supply chains, and serving ostensibly different civic functions. The same ratio of glass surface to iron frame. The same ceiling height relative to floor area. Specifically a ratio that acoustic engineers describe as producing a characteristic resonant frequency in the low end of the human perceptual range. The same orientation of the building's long axis relative to magnetic north. An orientation that in several documented cases required the architect to work directly against the logic of the available site. The Dublin Crystal Palace was built on a site that would have been substantially easier to develop, with the building oriented 30 degrees differently. The architect chose the harder orientation. No documentation explains why. This raises a simple but critical question. If these buildings were exhibition halls, temporary showcases for industrial products, why were there architects making decisions about acoustic resonance and magnetic orientation that had no functional relevance to the display of manufactured goods? The official answer is that they weren't. The official answer is that the dimensional similarities are explained by the constraints of available materials, by the economics of prefabricated iron production, by the natural convergence of engineers working within the same technical limitations. The official answer is that the orientation choices reflect site conditions and urban planning requirements that aren't always visible in the surviving record. The official answer is that I am seeing a pattern that isn't there. And I might be. I want to acknowledge that genuinely. Pattern recognition is a tool that misfires. The human mind finds structure in noise. I have asked myself whether that is what I'm doing, but then I return to Brandt's survey, and to the number 563, and to the second number that appears in that survey, a number he doesn't comment on, a number he simply records as a data point among data points. Of the 563 verified large-scale glass-iron structures erected between 1840 and 1900, 341 were deliberately demolished within 30 years of their construction. Not destroyed by fire or flood or war, deliberately demolished, taken down, removed. Let me talk about what happens when you demolish a building of this type, because it is not a simple operation, and the decision to do it is not a casual one. A glass iron structure of the scale we're discussing, buildings that covered multiple city blocks that contained structural iron members weighing hundreds of tons, requires significant investment to demolish safely. The glass must be removed by hand, pane by pane. The iron frame must be carefully disassembled because structural failure during demolition can be catastrophic. The foundations, which in many cases involve substantial concrete and stone substructures, must be excavated and cleared. This takes time, it takes skilled labour, it costs serious money, and it generates an enormous quantity of recoverable material, glass and iron, that has real commodity value. What this means practically is that the decision to demolish one of these buildings was never made lightly. There were always buyers for the recovered material. There were always alternative uses for the structure. The demolition of a major glass-iron palace required a deliberate institutional decision that this building should not continue to exist, balanced against a clear economic incentive to find some other use for it. And yet 341 of them came down within 30 years of their construction. Across countries that shared no administrative authority over each other, in cities that had no coordinating framework for architectural policy decisions, in a period before the kind of global communication infrastructure that would have made such coordination straightforward. I am not saying the demolitions were coordinated. I am asking what it would mean if they were, and I am asking separately what it means that they were not recorded as a coordinated campaign. Because if 341 large buildings came down across the world in a 30-year period for any single articulable reason, we would expect that reason to appear somewhere in the historical record. We would expect debates. We would expect newspaper editorials arguing for preservation. We would expect the kind of institutional record that any significant policy decision leaves: committee minutes, cost assessments, competing proposals, the documented record of a decision made by people who understood what they were deciding. The silence was deafening. Here is what the surviving demolition records look like. I've gone through a substantial sample of them. The justifications fall into a small number of categories. The first, the structure was considered temporary from the outset. This is the most common justification, and on its face, it's reasonable. Many of these buildings were constructed for specific exhibitions, explicitly described as temporary at the time of construction. The Crystal Palace was supposed to be dismantled after the 1851 exhibition. The decision to relocate it was an exception. But here's what the temporary justification doesn't address. If a building is genuinely temporary, you design it to be temporary. You use minimum material. You avoid expensive foundations. You build in the easiest possible orientation with the simplest possible structural logic. You do not spend the engineering effort required to produce a building whose dimensional ratios produce a specific acoustic resonance frequency. You do not work against the logic of your site to achieve a specific magnetic orientation. You do not build, in other words, the buildings that Brandt's survey describes. The second category, the structure was considered impractical for permanent use, difficult to heat, difficult to cool, prone to condensation. These are genuine engineering challenges, but they are manageable challenges, managed in fact in the glass-iron structures that did survive. Manageable challenges do not explain 341 demolitions. The third category, and this is the one that keeps appearing in documents from the 1870s onward, the structure was considered unsuitable for modern purposes. Unsuitable for modern purposes. I've read this phrase in demolition justifications from London, Paris, Brussels, Hamburg, Vienna, Chicago, and Sydney. It appears in different languages, in different administrative contexts, in buildings serving different civic functions across the same 30-year window. No elaboration, no specification of what modern purposes required that this building could not provide. No documentation of what alternative use had been considered and rejected. No record of a conversation about what specifically made it incompatible with modern requirements. Just unsuitable for modern purposes. And then the demolition crews. This is where the official explanation collapses. Let me tell you about the New York Crystal Palace because it is the most instructive case in the American record, and the one the official history treats most cursorily. The New York Crystal Palace was built in 1853 in what is now Bryant Park, in Midtown Manhattan. It was modelled loosely on the London original, but was in several respects more sophisticated structurally. It was designed by two architects, Georg Carstensen, a Danish architect who had designed the Tivoli Gardens in Copenhagen, and Carl Gildemeister, a German-American engineer whose other work in New York is poorly documented. The building opened in July 1853 for the exhibition of the industry of all nations. It housed 4,854 exhibitors from 23 countries. The exhibition closed in November 1853. The building stayed open as a public attraction. On October 5th, 1858, it burned. The fire started in the morning. The building was full of stored goods from a recent fair. Within 15 minutes, the structure was engulfed. Within half an hour, it was gone. The glass exploded outward in the heat. The iron frame twisted and collapsed. Very little was left to photograph. The official record attributes the fire to accident, most likely a candle or discarded match near stored combustible materials. What the official record does not address is this. In the weeks immediately preceding the fire, the building's primary tenant had been negotiating with the City of New York about lease renewal terms. Specific to those negotiations was a proposal to commission a systematic study of the building's structural and acoustic properties, a study that an engineer named Frederick Slade had apparently been advocating for several years. Slade believed, based on observations he had made during events held in the building, that the structure produced acoustic effects that had no obvious engineering explanation. He had petitioned building management for access to conduct measurements. I found Slade's petitions in the New York City Municipal Archive. There are 3 of them, dated 1856, 1857, and July of 1858. Access was denied each time on grounds of operational disruption. The 4th petition, which Slade apparently planned to file in October of 1858, was never filed. The building burned in October of 1858. Frederick Slade does not appear in any history of American engineering or architecture. The pattern repeats with unsettling precision. I want to be careful here about what I'm claiming and what I'm not. I'm not claiming the New York Crystal Palace was deliberately destroyed. I'm not claiming that Slade's petitions are evidence of deliberate suppression. I am pointing to the shape of an absence. A man who believed a building was doing something acoustically unusual, who tried 3 times to study it systematically, whose 4th attempt was rendered moot by the building's destruction, who then disappears from the record entirely. Gone. And I keep returning to a question the official history of glass iron architecture never seems compelled to answer. Why did nobody study these buildings while they existed? Not one of the major glass iron structures of the 1840 to 1900 period was subjected to systematic acoustic or electromagnetic study before its demolition. I've looked. Brandt's survey mentions 2 unpublished attempts to conduct measurements in glass iron structures, both apparently discontinued without producing results that entered any archive I've been able to access. In the same period, every other aspect of Victorian engineering was studied exhaustively. The acoustics of concert halls, the structural properties of iron bridge trusses, the thermal dynamics of glass conservatories. Victorian engineers were meticulous documentarians of what they built and how it worked. The absence of systematic study of glass iron palaces specifically is not explained by the era's scientific culture. It requires a different explanation, unless there was simply nothing unusual to study, nothing to find, buildings as unremarkable as the official history suggests. But here's what I can't reconcile with that explanation. Brandt's survey includes a section, typically overlooked, that I spent a long time with. It is a compilation of contemporary accounts, letters, diary entries, newspaper reports, institutional records describing the experience of being inside these structures during specific atmospheric conditions. The accounts cluster around 2 types of events. The first, thunderstorms. Multiple independent accounts from multiple buildings in multiple countries describe an unusual phenomenon during electrical storms. Not lightning strikes, not structural damage, something more subtle. A humming. A resonance felt in the chest as much as heard by the ear. Visitors describing a sensation one account from an 1867 letter calls vibration of the body's interior. A maintenance worker at the Munich Glass Palace, writing in a letter preserved in the Bavarian State Archive, describes the building during the summer thunderstorm of 1876 as singing. Not the creak of iron expanding or the rattle of glass in its frames, a sustained low tone he says he felt in his teeth. The second type, clear nights with specific atmospheric conditions, but us accounts describing luminescence in the glass that could not be attributed to reflected moonlight, a quality of the air inside that visitors struggled to characterize. An 1872 account from the Brussels Winter Garden describes a night during which visitors reported difficulty leaving, not from any physical compulsion, but from what the account calls a reluctance of the body that preceded and opposed the decision of the mind. I don't know what to do with accounts like these. They are anecdotal, they are unverified, they could be the product of suggestion, of the Victorian propensity for atmospheric description, of the genuine strangeness of standing inside an enormous glass structure on a night with unusual atmospheric conditions and no electric lighting. But there are a lot of them, across a lot of buildings, describing something consistent, and no one studied it. This is where I have to raise the world-spanning coordination problem. Because it is, as it always is in stories like this one, the most intellectually challenging part of what I've found. The Glass Iron Palace is conventionally described as a European invention, exported globally through colonial influence, and the prestige of the Great Exhibition model. This is partly true. The Crystal Palace was widely reported and widely imitated, but it doesn't explain everything. In Japan, in the years immediately following the country's forced opening to Western trade, there appears in the historical record a cluster of large public structures described in contemporary accounts as glass buildings, not in the Western style, not the arched glass shed of the Crystal Palace, but in a distinctly Japanese architectural idiom that nonetheless shared the same fundamental material logic. A glass skin on a metal frame, enclosing a large public space, oriented with precision relative to the local landscape. Most of these structures appear in records from the 1870s and 1880s. Most of them are gone by 1910. The documentation is fragmentary, as Japanese architectural records from this period are fragmented by the upheavals of the Meiji Restoration. But the structural evidence appears in surviving engineering surveys of the sites, foundation systems inconsistent with the small commercial buildings that replace the glass structures, subsurface metal anchor points whose placement corresponds to the load-bearing logic of a glass iron roof. In India, in the years of late colonial administration, British engineering reports describe glass structures in major administrative centres, Calcutta, Bombay, Madras, that appear and then disappear from the record in the same window. The British colonial administration documented everything else in exhaustive detail. The absence of records about these specific structures in that administrative culture is itself a data point. In Brazil, in the rubber boom cities of Manaus and Belém, glass iron structures appear in city records from the 1880s and 1890s, with no obvious explanation in terms of local industry or civic need. Manaus's famous opera house, completed in 1896, is always cited as evidence of the city's rubber-era extravagance. Less cited are the two large glass structures that appear in photographs from the same period and that appear in no official record of what they were for, gone before the rubber boom ended, gone before anyone thought to document them systematically. I am not saying these structures were all part of a single network. I'm asking what it would mean if they were. I'm asking why the same material logic, glass skin, iron frame, specific dimensional ratios, specific orientation, appears independently in cultures that the conventional narrative says were not in the kind of sustained technical contact that would produce this convergence. Diffusion explains copying. It does not explain why indigenous building traditions in Japan produce glass iron structures in a Japanese idiom before significant Western architectural influence had penetrated Japanese building practice. It doesn't explain the Brazilian glass structures that appear with no documented European architectural involvement. Something was understood. Something about what this combination of materials at this scale, in this orientation, does. And that understanding appears to have been older and more widespread than the official story of Victorian ingenuity allows. This raises a simple but critical question. What were these buildings for? The question the official history answers without hesitation. Exhibitions, commerce, public gathering, the display of manufactured goods and national prestige. And for some of them, in some periods, that answer is sufficient. But here's what I keep coming back to. The exhibition function of these buildings lasted typically months. The buildings themselves were built with foundation systems and structural engineering consistent with permanent occupation. The energy and expense invested in their construction was calibrated not to the exhibition function, but to something else, something permanent. What would you build a permanent glass iron structure for, if not exhibitions? Think about what a large glass iron enclosure does, materially, physically, without any attributed intention. It creates an interior environment that is electrically continuous with the sky. Glass is not a perfect insulator, particularly not the glass of the Victorian period, which was inconsistent in composition and contained significant impurities that affected its electromagnetic properties. Iron is an excellent conductor. A glass iron structure of the scale we're discussing creates, in effect, a large conductive mesh in contact with the atmosphere above and the ground below, enclosing a space whose dimensions produce specific resonant frequencies. Tesla knew this, not from glass iron palaces specifically, but from the same underlying understanding. His Wardenclyffe Tower, and the project he spent the last financially functional years of his career on, was designed to interact with the electromagnetic relationship between the ionosphere and the Earth's surface to access what he called the wheelwork of nature. Tesla spoke occasionally about what he believed had been known before, not invented by him, known and lost. In a 1916 interview in the Electrical Experimenter, he referred to structures in the ancient and early modern world that had achieved, in his assessment, effects on the human body and on the local electromagnetic environment that he was attempting to reproduce by scientific means. He called this the recovery of a lost principle. What principle? He didn't say. Or if he said, that part of the interview doesn't appear in the surviving record. The silence was deafening. I want to return to where I started, to Brandt's survey, to the number 563, to the 341 deliberate demolitions in a 30-year window. Because here's the thing about deliberate demolitions. They generate records, contracts, invoices, work orders, material disposal records, correspondence between building owners and demolition contractors, and city authorities, and the buyers of recovered material. Those records exist. For most of the demolitions in Brandt's survey, the operational records of the demolition itself are accessible in various city and institutional archives. They are, for the most part, routine. The logistical records of taking a large building apart. What is not routine is something that appears in a subset of these records, not in all of them, not consistently enough to establish a pattern with certainty, but in enough of them, across enough different countries and administrative contexts, that I noticed it. In the demolition records for a specific subset of glass iron structures, the ones Brandt identifies as having the most precisely engineered dimensional ratios, the most precise magnetic orientation, the most sophisticated internal acoustic geometry, there are references to a secondary removal operation that preceded the main demolition. The demolition contracts for these buildings describe a preliminary phase, listed variably as internal component removal, infrastructure clearance, or, in several cases, simply preparation work conducted before the main demolition crews arrived. This preliminary phase is always conducted by a different contractor. The preliminary contractor is often identified only by initials or a company name that does not appear in any other business record of the period. The work conducted is not described in the contracts. It is listed as a category of work billed at a rate and closed without itemization. What was removed from these buildings before the demolition crews arrived? I don't know. The records don't say. And the people who conducted the removal, whoever they were, do not appear to have left any other trace in the historical record. Gone, not suppressed, not argued against, just absent. As if whatever was removed had never been installed. Once you see it, you can't unsee it. There are still buildings standing that were built in this period, in this tradition, in this material logic, and were never demolished. A handful, scattered in places that escaped the renovation campaigns of the late Victorian era. You can still find them if you know what to look for. There is one in a city in Central Europe, I'm being deliberately vague about the location, that was converted to storage use sometime in the 1920s and has remained essentially unchanged since. The glass is original, or most of it. The iron frame is intact. The subfloor is the original stone and metal construction. I visited it. I'm not going to tell you what I experienced inside because I don't have the framework to describe it without sounding like I'm claiming something I can't prove. I will tell you what I observed. The dimensional ratio of the interior space corresponds to Brandt's high precision category. The orientation of the long axis is 4 degrees off magnetic north, a deviation that an engineer I showed the plans to said was consistent with a deliberate adjustment for local magnetic variation rather than any site planning rationale. At the precise geometric midpoint of the floor plan, there is a circular depression in the stone floor, approximately 80 centimeters in diameter, filled with what appears to be lead. The lead fill is not original construction. You can see at the edges where the original stone was cut away and the lead was poured in afterward to fill something, to seal something. I showed a photograph of it to a materials engineer. She looked at it for a while, then she said, "That's a ground point. A ground point, an electrical grounding connection, sealed with lead at some point after the building's original construction and before its conversion to storage use. Sealed. Not removed, not documented, sealed." I stood in that building for a long time. The glass above held the afternoon light in a way I struggled to account for optically. The iron frame was silent in the way that large iron structures are never quite silent, but the silence had a quality I found difficult to attribute simply to the hour or the weather. I'm aware that I'm describing a subjective experience. I'm aware it could be explained entirely by the accumulated weight of everything I'd read before I stood there. I'm not claiming it wasn't. I'm noting that I noticed. Here is what I can document. Not speculate about. Document. 563 large-scale glass-iron public structures built between 1840 and 1900. Fewer than 12 surviving in original form. 341 deliberate demolitions in a 30-year window. A survey that no one published and few people have read. An engineer named Frederick Slade who tried 3 times to study the New York Crystal Palace's acoustic properties and disappeared from the record before a 4th attempt. A Japanese architectural tradition that produced glass iron structures before the relevant Western influence existed to explain them. Demolition records that reference a preliminary removal operation conducted by contractors who left no other trace. A lead-sealed ground point in the floor of a building in Central Europe whose dimensions correspond precisely to what you would specify if you were grounding something large. And Brandt's final pages, a section I found only on my second reading because it was so understated I had skimmed past it. Brandt writes that in the course of compiling his survey he encountered a consistent report from people who had actually worked in these buildings during their operation. Elderly maintenance workers, retired administrators, former attendants. The report appeared independently across interviews conducted in 3 countries. It was this, that the buildings felt different on certain days. that there were days when entering the building produced, in the words of one informant, a change in the condition of the body that was difficult to describe but easy to recognize once you had experienced it. A clarifying, an opening. A sense, several said, of the body becoming more itself. Brandt reports this without comment. He notes the consistency of the accounts. Then he moves on to his appendices. He doesn't ask what the buildings were doing on those days. He doesn't ask what they were doing at all. He compiles his data and files his survey with the Prussian Academy of Arts, and the survey sits in the Staatsbibliothek for 100 years, waiting for someone to find the footnote that leads them to it. Maybe that's all it is. A careful man recording what he found. The ordinary residue of history. Or maybe Brandt understood that the question his informants were pointing toward. What were these buildings doing? What was the body recognizing when it entered them? What was the source of the change? Was a question that he, in 1923, with the world that existed in 1923, could not safely ask. I don't know which of those it was. I know the buildings are gone. I know that what was in the ground beneath them was sealed, not removed. I know the people who might have explained it are gone too, retired and dead, and reduced to the kind of second-hand account that an architectural historian includes in a footnote without comment. And I keep coming back to one image, standing in that building in Central Europe, looking at the lead-sealed circle in the centre of the floor, looking up through the original glass, very greenish, slightly warped the way old glass is, at the sky above, thinking about what was sealed in the floor, thinking about what the glass was once connected to, thinking about 563 buildings that were built and oriented and then taken apart and removed and sealed over before anyone asked why. Not destroyed in a war, not lost to fire, most of them, not abandoned in a collapse, taken apart, piece by piece, carefully, by people who understood exactly what they were taking apart. I want to know what they knew. I'm not sure we're supposed to.